Start your engines, folks, because we are not just looking at a weather event today.
Oh, no.
We are looking at a weather history event. If you are listening to this, you are likely already seeing the clouds thicken, or maybe the snow is already flying past your window.
It's moved that fast.
There is a massive system unfolding right now, and we are going to get right into the thick of it.
Let's do it.
Welcome to Meteorology Matters, the podcast that dives deep into the science, chaos, and stories behind the weather that shapes our world.
This show was created by meteorologist Rob Jones.
Now let's get into today's episode of Meteorology Matters.
Right.
It's Friday, January 23, 2026. If you have glanced at a weather map or even just looked out the window in the last 12 hours, you know what's going on.
You can feel it.
The situation in the United States is intensifying rapidly. The map is basically lighting up like a Christmas tree with warnings, watches, advisories, everything.
The whole gamut.
We are tracking a massive winter storm. Some outlets are dubbing it Winter Storm Fern.
And others are using more colorful language.
I've seen nightmare thrown around. But whatever label you slap on it, the reality is that it is impacting over 200 million people.
It really is a staggering footprint. We aren't looking at a localized event here at all.
Not even close.
We are talking about a continuous system that stretches for 2,000 miles. It's impactful from the high deserts of the Southwest all the way up to the rocky coasts of Maine.
And I think that's what's so critical to get across today. This isn't just a snow day storm.
No, this is a multi-hazard event. We have heavy snow, crippling ice, and then life-threatening cold, all wrapped into one volatile package.
It sounds like the trifecta of winter misery. So our mission today is to unpack the science behind this beast. I want to understand why this is happening, how it got so big, and honestly, why this isn't just your standard January snowstorm. Because 200 million people is a lot of people to be in the crosshairs at once.
It's definitely not standard. If you want the headline, it's a textbook example of weather chaos. We are witnessing a collision of an atmospheric river with the polar vortex. It's a very complex atmospheric dance, and the result is what we are seeing on the radar right now.
Okay, let's slow down and unpack that, because usually when I hear atmospheric river, I'm thinking California getting drenched.
Right, West Coast event.
And when I hear polar vortex, I'm thinking of, freezing faces in Minnesota.
-50 wind chills.
Yeah. So how do these two distinct things conspire to create a 2,000-mile storm?
That's the fascinating part. It's all about the ingredients coming together at the exact right moment. So let's look at the synoptic setup. That's the big picture view of the atmosphere.
The whole board.
The whole board. We have winter storm alerts stretching from Arizona and New Mexico all the way to the I-95 corridor in the Northeast.
Which is just a massive slice of real estate.
It is, and it's driven by two main engines. Ingredient number one is the icy air. We have a piece of the polar vortex, that large area of low pressure and cold air surrounding the Earth's poles that has dislodged.
It broke off.
It's dipping deep, deep into the continental United States. That is providing the sub-freezing temperatures necessary to support wintry precipitation.
Because that's the cold tank. That's the freezer door being left wide open.
Precisely. That is the perfect analogy. But cold air alone doesn't make a storm. It just makes it cold.
Right, you need the moisture.
You need moisture. And that is where ingredient number two comes in. We have an active subtropical jet stream that is acting like a conveyor belt.
A fire hose.
It is. It's pumping deep moisture from the Pacific Ocean and, crucially, the Gulf of Mexico.
Ah, the Gulf. It always seems to be the fuel source for these big ones on the eastern side of the Rockies.
Always. It's the engine. And just a quick note on geography, we never say Gulf of America. It is always the Gulf of Mexico.
Got it.
So that warm, moisture-rich air is just surging northward. Now, imagine that moisture running headfirst into that Arctic air mass we just talked about. The collision. Exactly. You have a low-pressure system developing in the southwest, and it's acting as the mixing bowl. It grabs that Gulf moisture and flings it right over the top of the dense Arctic air.
So you have warm, moist air being forced to rise over cold, dense air.
And that is where thermodynamics takes over. As that air rises, it cools, it condenses. Because the surrounding atmosphere is freezing, it crystallizes. It just explodes into storm development.
Wow.
This clash of air masses is creating what we call a baroclinic zone, basically a battlefield between warm and cold that stretches across the entire country. That is why the storm is so incredibly wide.
It's almost like a slow-moving freight train that just keeps adding cars as it moves east.
That's a great visual.
So I want to walk through the timeline of this train, because if you are listening to this on Friday morning, the impacts are just getting started in some places, but others are in the crosshairs for later.
Right. So Friday Today, the focus is really on the Rockies and the plains. We are seeing snow and wintry mix starting up in places like Oklahoma, Kansas, and the Texas Panhandle.
The first cars of the train?
The first cars. As we move into Saturday, the system expands and intensifies. It pushes into the South and Midwest and hits the Appalachians.
So Saturday is the day for massive travel disruption for the whole middle of the country.
Absolutely. Total gridlock potential. And then by Sunday, the freight train reaches the East Coast. It impacts the I-95 corridor. You're looking at Washington, D.C., Philadelphia, New York City, Boston.
The big population centers.
Exactly. And because this system is large and moving somewhat slowly, the impacts linger. We are looking at snow and wind continuing well into Monday for the Northeast and New England.
So it's a long-duration event. This is not a hit-and-run where it snows for 3 hours and then leaves.
No, this is going to be with us for the entire weekend.
Yeah.
A marathon, not a sprint.
Let's talk about the white stuff. Because for a lot of people, the headline here is the snow. We are seeing reports of 10, 15, maybe even 20 inches of snow in some bands.
Some really impressive totals.
But what stood out to me in the data was the description of the snow quality. Forecasters are using words like efficient and fluffy. I think most people assume snow is just snow. Why does the texture matter so much to a meteorologist?
This is where it gets really interesting for the snow lovers and really dangerous for the road crews. It all comes down to something called snow-to-liquid ratios.
Okay, walk us through that math.
So, in a standard snowstorm, think of a sloppy, wet snow where the temperatures are hovering right around freezing. The ratio is usually about 10 to 1.
10 to 1.
Right. That means if you melted 10 inches of snow, you would get 1 inch of liquid water. That's heavy, wet snow.
The kind that creates a slushy mess and gives you a heart attack when you try to shovel it?
Exactly. That is heart attack snow. But this storm is different. Remember that polar vortex connection we discussed?
The Arctic air.
The air mass feeding this storm is Arctic. It is incredibly cold. So when snowflakes form in very, very cold temperatures, they tend to be lighter and fluffier. They don't stick together as much. They stack up with a lot of air in between them.
It's like a down feather pillow versus a wet sponge.
That is a great analogy. Because of this cold air, we are looking at ratios much higher than 10 to 1. We might see 15 to 1 or even 20 to 1 in some of these spots.
So for the exact same amount of moisture in the air, you get double the pile of snow on the ground.
That is the efficiency part. Even modest amounts of moisture from the Gulf of Mexico will translate into huge snowfall totals on the ground. The snow just piles up incredibly quickly.
That sounds deceptive.
It is. You might look outside, see it snowing moderately, and think, oh, it's not too bad, and then an hour later you have 3 inches on the ground.
That seems incredibly deceptive for drivers.
It is, and it catches road crews off guard because it accumulates faster than they can physically plow it.
Yeah.
We are looking at significant accumulation zones in the plains, in Midwest Oklahoma, Kansas, Missouri, Illinois, Indiana.
All primed for that deep, fluffy powder.
That's right.
And looking further east, it seems like the infamous snow drought on the East Coast is finally about to break. And break in a big way.
It certainly seems that way. The I-95 drought has been a topic of conversation for a long, long time. I mean, New York City hasn't seen a foot of snow from a single storm since 2021.
And Washington, D.C., I saw, hasn't seen a foot in a decade.
10 years. Think about that.
That is wild.
It is. But the models are fairly consistent right now. Cities like D.C., Philadelphia, NYC, and Boston are all staring down the barrel of 12-plus inches. For D.C. and Baltimore, this could be the biggest event in a generation of kids.
I want to geek out for a second on why the snow gets so fluffy. You mentioned the cold air, but I saw a specific term in the research notes, the dendritic growth zone.
The DGZ.
It sounds like something from a sci-fi movie. What is happening in that zone?
The DGZ. This is one of my favorite atmospheric concepts. It refers to a specific layer in the atmosphere where the temperature is between negative 12 degrees Celsius and negative 18 degrees Celsius.
That is a very specific window. Why that range?
It's all physics. In that temperature range, water vapor deposits directly onto ice nuclei to form large, branching snowflakes called stellar dendrites. Think of the classic paper cutout snowflake you made in kindergarten.
The big, six-sided, intricate arms.
The pretty ones, exactly.
The ones that look perfect.
Those large branching arms allow the snowflakes to interlock and trap a ton of air. That creates the fluff. Now, in this storm, Because the cold air is so deep, the dendritic growth zone is incredibly thick.
So the snowflakes are spending more time there.
A long time. They're falling through that perfect temperature range, just growing larger and more complex. So by the time they hit the ground, they are maximizing that fluff factor.
So we have a deep DGZ, high ratios, and efficient piling. That is great for skiers, maybe bad for commuters.
Very bad for commuters.
But as much as we talk about snow, there is a much more sinister side to this storm that we need to address.
There is. And frankly, this is the part that concerns me the most.
We need to shift gears and talk about the ice. Because while snow is disruptive, ice is destructive. And there is a very specific zone, a nightmare scenario, really setting up across the South.
This is the part of the forecast that keeps meteorologists up at night. We are identifying an ice corridor that stretches from northern Texas through southern Oklahoma and Arkansas,
And then continues east.
into northern Mississippi and Tennessee, and then it bends up into the Carolinas and southern Virginia.
That is a huge swath of the country, and frankly, an area that is not built for heavy ice.
Not at all. And the physics of an ice storm are very different from a snowstorm. To get ice, specifically freezing rain, you need a very specific and very dangerous vertical temperature profile. We call it the warm nose.
The warm nose. Explain that mechanism. How can it be snowing in the north and raining ice in the south, all from the same storm?
So imagine a slice of the atmosphere from the ground up. At the surface, where we live, the temperature is sub-freezing. It's cold. 28, 29, 30 degrees Fahrenheit.
Below freezing.
But if you go up about 5,000 to 10,000 feet, there is a layer of warm air that is above freezing, pushing in from the south. That is the nose of warm air punching into the cold.
Okay, so the precipitation starts as snow way up high in the clouds.
Right. It falls as snow, but then it hits that warm nose and melts completely.
It turns into rain.
It becomes liquid water. But then as it continues falling, it exits that warm layer and re-enters the cold layer near the surface.
But it doesn't have time to turn back into snow.
No, there isn't time. It becomes what we call supercooled liquid. It stays liquid even though it's below freezing.
That sounds unstable.
Very. But the instant that supercooled raindrop hits a power line, a tree branch, or road surface that is below 32 degrees, snap. It freezes instantly on contact. It creates a glaze of clear ice.
And that accretion builds up fast. We're seeing forecasts of 1/4 inch to 3/4 of an inch of ice accretion.
And to put that in perspective, 1/4 inch is usually the threshold for nuisance power outages.
A few branches down.
Exactly. Once you get to a 1/2 inch of ice, you are talking about hundreds of pounds of extra weight added to a single span of power line. It brings down the lines. It snaps massive tree limbs like twigs.
And 3/4 of an inch.
That is crippling. That is catastrophic infrastructure damage that can take weeks to repair.
And there's a specific geographic setup causing this in the east, right? The Carolinas and Virginia seem to be in a particularly bad spot because of the mountains.
Yes, that is a phenomenon called cold air damming, or CAD.
We hear that term a lot in the mid-Atlantic. What is the mechanism there?
It's crucial here. We have a very strong high-pressure system, about 1040 millibars, which is incredibly strong sitting to the north.
Pushing cold air south.
It is funneling dense, heavy cold air down the eastern side of the Appalachian Mountains.
And the mountains act like a physical dam against the air.
Exactly. The cold air hits the mountains and gets trapped. It can't go west, so it just pools there in the Piedmont of North Carolina and Virginia. It forms a wedge of freezing air at the surface that just refuses to budge.
So it's locked in place.
Locked in. So even if warm air tries to move in aloft, that surface cold is not going anywhere. That prolongs the freezing rain event significantly. Places like Charlotte, Greensboro, and Richmond could see hours upon hours of freezing rain because of this damming effect.
It sounds like a recipe for widespread power outages.
A terrible one.
And that leads us directly into the next danger.
Sure.
Because usually when the power goes out, it's bad. But when the power goes out and you are facing the kind of temperatures coming behind this storm, that becomes a life safety issue.
This is the 1-2 punch we are concerned about. Punch 1 is the storm, the ice knocking out the power, snapping the lines.
And punch 2 is the cold.
Punch 2 is the Arctic air rushing in immediately behind it.
We are talking about record-breaking cold, aren't we?
We are. In the upper Midwest, North Dakota, Minnesota, we are forecasting wind chills dipping to -55 degrees Fahrenheit.
-55.
That is frostbite in minutes on exposed skin. But even further south, where the ice is hitting, temperatures are going to plummet well below freezing and stay there for days.
So if you lose power in Memphis or Little Rock or Charlotte, you aren't just sitting in the dark. You are sitting in a rapidly freezing house.
Precisely. and recovery becomes so much harder. Crews can't fix power lines when the wind chills are dangerous or when the roads are, well, skating rinks.
And speaking of skating rinks, we need to talk about the flash freeze.
Yes, the flash freeze.
Yeah, explain that sequence.
As the cold front sweeps through, temperatures drop incredibly fast. So all that slush, rain, or wet snow on the roads freezes solid. It turns into concrete ice.
And you can't treat it.
Well, here's the kicker. Sodium chloride loses its effectiveness when it gets too cold.
Oh, really?
Yeah. Once you get below about 15 or 20 degrees Fahrenheit, salt stops melting ice efficiently. So we could see roads that are literally impossible to treat. They'll be impassable.
That is terrifying for drivers. And you mentioned something earlier in our prep that I thought was a myth, but apparently is real. Exploding trees?
It sounds like a tall tale, doesn't it? But it is absolutely real. In these extreme cold drops, like when you go to 20 degrees Fahrenheit rapidly, the sap inside hardwood trees like maples and oaks can freeze.
And water expands when it freezes.
Right. And if it freezes and expands rapidly enough, the pressure builds up inside the trunk until POP.
No way.
The tree literally splits or bursts. It sounds just like a gunshot going off in the woods. It's a testament to just how brutal this cold air mass is.
That is wild. Nature is so powerful. Let's talk about the human impact of all this, because 200 million people impacted means 200 million lives disrupted. We are already seeing the travel chaos begin.
It's cascading quickly. Flight cancellations are already topping 1,200 for Friday and Saturday. Airlines are issuing waivers across the board, which is a sign they know planes aren't moving.
And the roads, I mean, I-10, I-20, I-35, I-40, I-95, that is basically every major artery in the eastern half of the country.
Every single one. And remember, even if the weather is fine where you are, the ripple effect in the aviation system is real. Crews get displaced. Planes get stuck in Dallas or Chicago. You might be in Miami with sunny skies, but your plane is frozen to the tarmac in O'Hare. The whole system grinds to a halt.
We are seeing a lot of governors declaring state of emergencies. Texas, Oklahoma, Arkansas, Mississippi, Alabama, Georgia, the Carolinas, Virginia, Maryland.
The list keeps growing.
It sounds scary, but what does that actually mean operationally? Is it just panic?
No, it's important not to see that as just panic. A state of emergency is a procedural tool. It unlocks resources.
It's a switch they flip.
It is. It allows the governor to mobilize the National Guard to help with stranded motorists or check on vulnerable people. It frees up funding for pre-treating roads. It waives certain regulations for utility trucks crossing state lines to help restore power.
So it's about preparedness, getting the assets in place before the ice hits.
Exactly. For example, in Texas, Governor Abbott has been very vocal about ensuring the ERCOT grid is ready. They are trying to avoid a repeat of past disasters.
And I saw in NYC they are recruiting emergency snow shovelers.
It's all hands on deck.
Okay, let's pivot to the listener. If you are in the path of this thing, which statistically you probably are, what do you need to do right now? We have compiled a Meteorology Matters checklist.
And the time for preparation is closing fast, so action is needed now.
First up, power.
Assume you will lose it. Charge everything, your phones, your tablets, those portable power banks. If you have rechargeable lanterns, juice them up.
And you had a pro tip for the fridge.
Yes, turn your fridge and freezer to their coldest settings right now.
Why is that?
It super cools the food. If the power goes out, you keep the door closed and that thermal mass stays cold longer, buying you precious hours before food starts to spoil.
That is smart physics. Next on the list, water.
If you are on a municipal supply, you're probably okay, but you should still drip your faucets. Moving water doesn't freeze as easily, and that can prevent your pipes from bursting and causing a massive flood inside your house.
And if you're on a well?
If you are on a well that needs an electric pump, fill the bathtub. Fill every pitcher you have. You need water for flushing toilets and hygiene if the power and therefore your pump fail.
Next up, the car.
Keep the tank at least half full.
Is that to prevent the gas line from freezing?
Partly, yes. But mostly it's for warmth. If you get stranded or if your house loses heat and becomes uninhabitable, your car becomes your lifeboat.
A warming station.
A warming station. You can run the heater periodically to warm up, but, and this is critical, make sure the exhaust pipe is clear of snow before you do.
And that leads to the biggest safety warning we have.
Carbon monoxide, the silent killer. Every time we have a major ice storm, we see a spike in poisonings.
It's so tragic and preventable.
It is. People get desperate for heat or power. They run generators in the garage, or they try to use a gas grill indoors for heat.
Never do that.
Never, ever run a combustion engine or grill inside or in an attached garage. The fumes are odorless and they're deadly. Keep the generator outside, away from windows.
Excellent advice. And finally, stay off the roads. Don't crowd the plow, is the saying. But ideally, don't even be on the road to see the plow.
If you can stay home, please stay home. It's the safest place to be.
So, to recap the situation, we have Winter Storm Fern, or whatever you want to call it. It's a historic system covering 2,000 miles, impacting roughly 235 million people.
It brings heavy, efficient snow to the north, crippling ice to the south, and is followed by a brutal, life-threatening Arctic freeze.
The weather is a powerful force, and understanding the science helps us prepare. But here is one final thought to chew on. We talked about the human factor in meteorology. We trust the models, we trust the radar. But in an event this complex, with ice lines shifting by 5 miles making the difference between rain and ruin, the human intuition of local forecasters is still the most valuable tool we have.
Oh, absolutely.
The models give us the data, but the people give us the context.
It is so true. The nuance is everything. You can't get that from a computer model alone.
If you want to stay ahead of the weather and get that nuance, make sure to follow meteorologist Rob Jones.
Absolutely. He's fantastic. You can find him on Instagram at meteorologist, simple and easy.
On TikTok, look for TV Meteorologist.
And on YouTube, search for Rob Jones Hurricane. You can find the entire Meteorology Matters podcast playlist there as well.
And please, if you found this conversation helpful today, like, follow, comment, and rate the podcast. It really helps us get this vital information to more people.
It really does. It makes a huge difference.
You've been listening to Meteorology Matters, created by meteorologist Rob Jones.
Stay safe out there, stay warm, and please, keep an eye on the sky.
Thanks for listening, and remember, meteorology always matters.